Off pause. We're going to take a look at Chapter 8. Chapter 8 is all systems of equations. And so in 8.1 it's graphing systems of equations. And in graphing there's some possibilities that show up with this. So let's go through all of those first so we get an idea of what ends up taking place with those. So if you graph something, you know that if you're graphing it, you need to have it set up into your y equals mx plus b. So y equals mx plus b is our format. So if you put it in this format, all of your problems solve for y. So you get y all by itself if we can possibly do that. So we get y all alone. But in our graphing, you'll graph a line, and then you'll graph another line. And if those two lines that you happen to graph cross each other at this point, that is where they end up coming out at. Move it up. Like that. Okay. So if they are crossing each other at this point, then what we have to do is be aware of that, and that's the spot where they cross at. So in this case, if we are out -1 to the x-intercept, or x value, and down 2, our point that this crosses at is -1, -2, and that is said to be the solution for that graph. So they'll cross at one point. The other possibility that we can have with graphing is that if you graph two lines, and one line graphs like so, and the other one graphs like so, what do you notice about those two? They're parallel, right? So, and way back when in Chapter 4, we learned that if we have parallel lines, the slopes are the same. And they never cross. And they never cross. So if they never cross each other, and we happen to have that for our values that we have in there, they never cross, this one has no solution. So we can have that type of a line that happens. The other one that occurs is if we are graphing our lines and we have two values that end up going like so. The first line comes in and does this. The second line comes in and it is right on top of the other line. So what does that mean? Well, if they're both on top of each other, that means that we have two identical lines. And since we got two identical lines, those two are going to be right on top of each other. So we have many solutions, or infinite number of solutions. So we have all kinds of solutions with that one. So that one doesn't have just one answer, but it's got a whole bunch. So any point that I happen to stick on this line, and wherever that point happens to be on that line, that ends up being a pattern or a set of points that end up making that graph come together, so that you end up having your combinations in there. And so we end up with our pieces that end up creating or making that thing work. Okay so far? Okay, so that's our three possibilities. Now within Hawks, if we take a look, and we're going to try something here and see if we should be able to pop back and forth here into Hawks and go into 8.1 for our lessons. And if we take a look in 8.1, see if I can get to my practice here. The reason I wanted to show you it in here is because your combinations that you end up with for your graphing pieces end up, and let me write these guys down here so we can go back and end up solving them. It says on the top of here, it says determine if the ordered pair of 2, -1 lies on both of the lines in the systems of equations by substituting the point into both equations. So we've all did substitution before, and of course substitution means that I just simply need to replace the values that are in here within our x and our y, plugging in 2, because that's our x value in for x, and -1 in for y, and we're going to find out whether that ends up working or not. And so let me shrink this, and let's go back to our equation that we happen to have here, and let's see what we end up with. So if I take a look at this one, and my point was 2, -1, 2, and I want to know if that works. So plug -1 in where x is at, so 3 times the -1 minus 2 times 2. Does that equal 8? Was it the other way? Oh, 2 -1, thank you. 2 -1. If I put it in this way, it's probably not going to end up helping me out, is it? So let's try it the other way. So 3 times 2 minus 2 times the -1, does that equal 8? What would we all say? Well, 3 times 2 is 6. -2 times the -1 is a +2, so that does equal 8. But if it works for one and doesn't work for the second one, we've got a problem. So we got to go 3 times 2 minus 3 times the -1 equals 9. And 3 times 2 is 6. -3 times the -1 is a +3. And so it equals 9 as well. So we could say, yes, that does end up being the solution for that. And so if I go back into my Hawk stuff, and hopefully my practice will pop back up, and we can say yes. Okay? And so then if I let's go to skip, we're going to skip that one even though we know the right answer for it. And let's see what the next one pops up as. Because within Hawks, see if it does do this, it gives you things that look like this. Now that one's not the nicest, prettiest looking problem, is it? So let's write down what we've got for our equation. So it's like having 3 parts. This is our system that we happen to have. Over here, let me get this keypad thing out of the way here. So we can see everything we've got. Is a linear equation. You write both equations in here. Now what goes in front of x is of course your slope. The thing that goes at the end is your intercept, and that goes for each equation. The first equation goes here, second equation goes there. And then down here, based on what your graph comes out to be, remember we talked about the graph having straight lines or lines that crossed each other or lines that were on top of each other. Depending on that, you have to determine what you happen to have for that and what comes out of it. So let's get these numbers written down here. And Hawks has a tendency to get some pretty big numbers in there that we need to take a look at. And I know that's got the sun on it again for you up here, but let's shrink this. Shrink that. And we're back to this piece. So because we've got fractions in here, our best bet is to do what? Get rid of them. So we're going to multiply everything in there by 4 over 1 to remove those, and we're going to end up with a negative 20x. No, we won't end up with negative 20x. We'll end up with negative 5x because the 4's cancel. 4 times negative 7 is a negative 28y. And this 4 cancels, leaving me with 89. Now I can move my 5x over, so I'm going to add 5x to both sides. And so I get a negative 28y is equal to 5x plus 89. Divide by negative 28. And what am I left with? Well, I'm left with y is equal to a negative 5x over 28 minus 89 over 29, or 28. And we'll go back and put that in a second. We're going to get both of them done here, and then we can plug it in and see what happens with it. So then if I work on this one, 6, 4, and 12, what should I use? 12, yeah. 6 will go into 12 twice. 2 times a negative 5 is a negative 10x. 4 goes into 12, 3. 3 times 5 is 15y. And 12 goes into 12 once. 1 times a negative 35 is a negative 35. Move my 10 over. And then end up dividing by 15. And each one of these reduces, so 5 goes into 10 twice, 5 goes into 15, 3. 5 goes into 35, 7, and 5 goes into 15, 3. And so there's my 2 pieces. We okay with that part? So we got those 2. And if we bounce back to Hawks again, so it's kind of like what you'd end up doing on your side of the paper here. So over here in front of my x, for the very first equation, I'm going to put in a fraction. So I need my fraction bar over here. And it's going to be a negative 5 all over negative 28. And for the y portion in there, or the intercept portion, it's a negative 89. Whoops, I need a fraction in there. Get a fraction first. Fraction, negative 89. And you would hate to have to graph this by hand, and I don't blame you. It would not be a very easy thing to graph. But in Hawks, it lets you put the blue line. So now my blue line that's in here is representing that equation. Then if I go to the second one, it is going to be represented by another fraction. And we solved it to be 2 over 3. And we solved our y-intercept is going to be negative 7. Whoops, I need a fraction again. A fraction bar in there. Negative 7 over 3 as well. And it's graphed it. Okay, so I have a purple line and a blue line. So where's my answer? Well, notice they both cross each other. So how many solutions should I have? Just one. And it should be at the value of negative 1. And what was the other one? Negative 3. And let's just see if we're right on this one. We'll put submit in there for that one and see we got it correct. So that's good. Okay. If we go on, it'll probably pop up another one that's in there that we end up doing the day. Yes?
How did you, on the second one, how did you get 2/3 and 7/3? How did you get that?
How did I get that? Okay. Let's leave this guy up here for a second. Let's go back and I'll show you on here. I ended up getting a 7/3 because when I moved this 15 over here, I took that and reduced it. Because 5 will go into 35, 7, and 5 will go into 15, 3. So that's how. Now, be really careful in Hawks because if you notice when we plug this thing in, they had a box with X plus a box at the tail end. When you enter this piece in here, if it's negative, of course you got to make sure you put a negative in there. Because they always have a plus sign here, if this is negative, I need to put a negative in that part. So you got to be really careful with that because they're not really setting it up with that negative sign that you would need in there if you're going to write it the way in which you normally would. So be careful with that you make sure you put your negative in there. Okay? The reason I'm doing this with the Hawk stuff today is because they don't end up graphing the way in which we've normally graphed, so their combinations that they happen to have are a little bit different. And so if I did it on sheet of paper, we would have to end up having the graph there, but Hawk shows you a different way of doing that. So it's not graphing with the graphs, it's that it puts it in for you. So our next one that's up here is the sum. The sum of two numbers is 35, and their difference is 15. What are the two numbers? Let x equal one number and y equal the other. So they come down and they give us, of course, x plus y, or the first two numbers added together gives you 35. Then their difference is 15. So then what we need to do with this equation
is, again, write these down. Notice the setup is similar. You have to get it into y-intercept or slope-intercept form, and then you need to figure out whether you have one answer or two. So let's write these guys down so that we can have them in our notes. So x plus y equals 35, and x minus y equals 15. And then let's go back and take a look at those and see if we can solve them for what we happen to have here. It's a lot of maneuvering today. Okay, so if I get this solved for y, all I simply need to do is x plus y equals 35, just simply subtract an x, and I get y equals a negative x plus 35. And the second equation is x minus y equals 15. And on this one, I'm going to minus x. Leaves me a negative y equals a negative x plus 15. But I'm not done, am I? No, because I got to get y all by itself, so that means I divide everything by negative 1. So then I get y equals negative x and a negative 1. It gives me a positive x minus 15. And so when I get both of those answers, then I can go back into Hawks and put them in. So really, your stuff that you're working with in here is a little bit different of what you've got happening. So if we put the first one in, I'm going to have a negative 1. Now again, in Hawks, I've always told you don't put the 1s in front of x's, but in this case you need to, because you need to tell it what is in front of there. So I get 35. And it graphs my blue line. Go to my purple. And that was 1. And over here with the other part is a negative 15, because we changed our signs in there. And it's graphed my purple and my blue line, so now they're on top of each other. So how many solutions? Just one. And where is it at? Well, now notice my scales are different. My scales are in increments of 10 and increments of 10 going up here with a space in between, so that's every 5. So if I look at my x's for where it's at, I'm really at 25. And where it crosses on y is at, if I go backwards, I can find out that that happens to be at 10. And so therefore, that's my answer. And if I hit submit, that will pop in there. So it will be. Okay? Making sense? Okay, good. This one, it says determine the solution to the systems of equation represented by lines of the graph. Check your solution by substituting both into your equation. So this one, they've already graphed it for you. So is there a whole lot I got to do with it? Nope. So the blue line is the first one. The purple line is the bottom one. All I need to do is find out that I am at 1, 2, 3, negative 1. And so the work that you have in there is, it's pretty straightforward of what you do have to do. Now you know you have it right if you plug it back in, so that then you can know whether that answer does end up working out correctly. And we'll take a look at another one here, and hopefully we've got, are we okay with that one, do you think? So all we got to do is you got to go back up, solve for y, so I'm going to move the 2x over. And so if I solve that one's pretty straightforward. So I'm going to end up with a 2 in front of x and a 5 at the tail end. We okay with that part?
And then if I look at the bottom one, I need to move the 8 over. So that's going to give me 4y equals 8x plus 20. Divide everybody by 4, so 8 divided by 4 is going to give me a 2. And 20 divided by 4 is going to give me 5. So what happened? Well, now if I go back and look at these, they're both the same. See, Hawk should have put an extra blue line in here so that we knew that both were on top of each other for that one. And so what do I have for my answer? Infinite number. Yep. And so it's that easy. So you're starting to see with these that you're getting an idea. And then the only other one that could possibly pop up, and I don't know if I can cooperate with it. Maybe do that. As we'll see in a second, is if you have two that are parallel to each other. And here it is again, the two equations are identical to each other with those. And this one's not going to be one of those. I can tell you now because I had 8 in there, and we had some other stuff in there, we probably would have been okay, but they're not going to be parallel to each other, they're going to cross in that situation. So are you okay with that part? What do you guys think? Yes? Okay. And that's basically all what you need to do with 8.1 is just to go through and back with those pieces in there. So that's the stuff that's taking place with that. So go back to the sheet of paper here and see what happens. Okay? Yes? All right. In 8.1 there's actually 3 different types of story problems that can pop up into this problems in this area. And the first one in there is the sum of two numbers is 55 and the difference is a negative 15. That's like the one we just left off with. So you'd have to come up with what your two equations would be. So the sum of two numbers, so what does that mean? Yep, adding. So that means x plus y equals 55. The difference is a negative 15. So what does that mean? So it's going to be x. Difference means to subtract plus minus y equals a negative 15. And now to finish it, of course, because we're in graphing, we would end up taking these two and end up solving them for y. So that means I need to subtract an x from this side so that y equals a negative x plus 55. And you would enter that into your hack stuff. And over here, the same thing. I would subtract x. And then divide by a negative 1 because x is, or y is not outside. So then I would end up with y is equal to x plus 15. And I would end up plugging those two in to graph them and come up with what my solution would be. Okay? Now I don't have the graphs here because I don't have that problem in Hawk so I can plug my stuff back in. But you plug it in just as we've been doing. Is that okay? Okay, good. The next one that pops up is the perimeter of a rectangle is 190 meters and the length is 15 meters longer than the width. Find the dimensions of the rectangle. Let x equal the length and y equals the width. So what would we need to do with this thing? Well, first off, we need to know what perimeter means. What's the perimeter of a rectangle? What's our formula? Perimeter of a rectangle. 2L plus 2W, okay, is equal to 190. Perfect. But then it goes on and it says the length is, now be careful here, because is means equals, right? Length means L. So if I go through, the length is 15 meters longer than the width. So what does that mean? It means L is equal to 15 plus longer than, so that means addition, longer than the width, and I have them in L's and W's, and then if we read on it says that x equal length, so that means I really have 2x plus 2y is equal to 190, because width is y, so that means I have x is equal to 15 plus y. Now the reason they went with x's and y's in this problem wanted to use L's and W's, you would have to set your graph up as an L and W axis instead of X and Y axis to do that one, so they just plugged it back in and made it into Y. So then we would solve it by moving the 2x over. Oops. Then divide everybody by 2. And when I do that, I find out I have y is equal to a negative 2x divided by 2 is a negative x. Then 90 divided by 2 is 95. 95, was it? No. 95. Yeah. So you plug that into your help stuff, and it will do the graphing for you. Okay? So let me move it up a little bit here for you. Okay? Make sense? Okay. Then the last one was to determine if the ordered pair, -4, -4, lies on both of the lines in the systems of equations by substituting the point into both equations. So, is this going to be a true statement? So, -4 goes in for x, -4 goes in for y. Does that indeed equal 0? 2 times a -4 is a -8. -4 times a -4 is a plus 16 minus 8. Does it equal 0? What would you say? Yes or no? I think I'd say yeah. Okay? It does end up equaling 0 because a -8 and a -8 is a -16 plus a positive 16. So that one works. Does the other one work? 2 times a -4 equals 4 times a -4. 2 times a -4 is -8, but 4 times a -4 is a -16. So what would we say? This would definitely be a no, and you would of course enter that into hats. Because both have to match. If you're going to make it work, they both have to be identical to each other. And so they didn't end up matching in the end, so that would be your answer to that one. Okay? So I think that pretty much takes care of 8.1. And what we have to do, oh, there is one more, isn't there? There's one more story problem. And that one is just like the last one that we did. And it ends up fitting into the fact that we have 3, -3, but I think you're okay, correct? So what we would do is we plug those into these pieces, find out whether the two matched each other, and then go from there. Okay? All right or not all right? Okay, good. And that one again is just like an example. If you want, you can work it through and see what ends up coming out of that one. Okay. All right. So that was 8.2 is the next section, and 8.2 is substitution in solving systems. Of equations. In substitution, it means exactly what you think. You're going to replace a letter with a value it is equal to. So in substitution, they still give you a system of equations. And that system of equations might be y equals a -2x plus 5, and x plus 2y equals 1. Now when we did graphing, we ended up with a bunch of strange numbers sometimes within that graphing patterns that we were doing. And in that case, it wasn't always as accurate and it wasn't always as easy to come up with your answers. So substitution is another tool in your toolbox, because we talked about toolboxes and putting things in there to solve different problems. And what makes this one good for substitution is if you notice the first equation, it's telling me y is equal to a -2x plus 5. You see that part? And because it tells me y is equal to this piece, what that means is that I can take this thing, and I can take this whole piece, and take it down here, pull out y, and stick this thing in its place. And then it all becomes an algebra problem after that. So if I take this and replace it in there, I'm going to have x negative 2x plus 5 is equal to 1. So when you replace it, you're sticking it in the center. Now what this will do for me is notice now I have only one single variable, and the thing with systems of equations is you have two variables. You have x's and y's, or you have a's and b's, or you have all kinds of combinations, but there's always two letters in there. Okay? So if there's two letters that you happen to have in there, you need to solve it and figure out what they're going to be. So when we graph things, we looked at two lines coming together and they crossed each other at a certain point, and that was the answer to that system. Here, we need to find where that point's at. We don't see it, but we can find it by solving for the letter. So if I finish this, I have x. Distribute the 2 times everybody, so 2 times a negative 2 is a negative 4x. 2 times 5 is 10, equals 1. Combine my x's, a positive 1 and a negative 4 is a negative 3x. And then, if I go through and figure out what this happens to be, I'm going to move my 10 over. So I get a negative 3x is equal to a negative 9. Divide by negative 3. And what do I find x to be? 9 divided by negative 9 divided by negative 3 is a positive 3. Okay? So once I've found one piece, am I done? I'm not finished yet. This is only one part. Now I need to go back and find the other part. So if I go find the other part, I'm going to take 3, take my first equation, because it's already solved for y, and put a negative 2 times 3 plus 5. And what's y going to equal? Negative 2 times 3 is a negative 6. Negative 6 plus 5. And we're going to find y is equal to negative 1. Okay? Now, if I want to write this out as my answer is going to be in point format, where it's alphabetical. X comes before y, so therefore it's a 3, negative 1. If I want to check it, I know I just finished this one, so it worked there. If I pull the second one back out and put it in there, 3 plus 2 times a negative 1 is going to equal 1. Is that true? 3. 2 times a negative 1 is a negative 2. And 3 plus a negative 2 does equal 1, so I know I did it right. So every problem that you have, you can check these to know whether you got your correct solution for it. Okay, not okay. So far, so good? Okay. Now, within substitution, as within all of the other parts there, we of course got our steps that we need to go through, so I probably better give you those. So first step is solve one of the equations for one of the variables. Okay? So we're going to solve one of the variables. So whichever variable you happen to pick. So again, if you've got one that's already solved like that last one we just did, you got it already in your hands there. So step 2 is substitute the value for step 1 in place of the same letter in the second equation. Okay, so we'll put it in place of it. Step 3 is solve the new equation. Which gives one of the answers. Step 4, substitute 3's answer into the answer from 1 to solve for the second variable. then step 5 is to check. I got that on there. And I didn't do that. So the last one is to check it. And make sure that you have it in your place. So make sure you check it. So it doesn't get broken. Tell me what that solution will be. Okay? Get caught up on writing a little bit there. So basically, these and solving them are just algebraic methods that we use to come up with our solutions and end up coming out to be. And that ends up taking place with this. Okay? So far, so good? Okay. So if I look at my next example that's here, what letter would you think I should solve for? So if I look at this top one, the thing with substitution that you want to always look for is whether you have a variable y that could be all by itself. Notice there's no number in front of I, so I could get y all by itself quite easily. So if I do my step 1, I'm going to take 3x plus y equals 1, and I'm going to solve for y. So I'm going to minus 3x. So that leaves me with y is equal to a negative 3x plus 1. Step 2, I'm going to take this piece, and then I go to my second equation. Don't plug it back into itself. Okay, it doesn't work. So make sure you don't put it back into what you had solved before. So you've got to go to that second equation. So if you go to the second equation, you're going to have 6x plus 2, replace y with what you just found. And then go through and solve it. So if I go through and solve it, I'm going to have 6x. 2 times a negative 3x is a negative 6x. 2 times 1 is a plus 2. And then that equals 10. Well, what happened? Well, if I take these, those guys go away, don't they? And I'm left with 2 equals 10. Is that true? Okay, this is false. So if you remember back when we talked about in section 8.1, when we had a graph that was 2 parallel lines, remember that? If I looked at this equation, if I were to take it and plot it and put it into a graph, I would find out that they're identical to each other, the slopes are the same, but my intercept is different. And so when you end up with something that's false, that's going to be a no solution. So you're going to have a no solution with this one because it turned out to be false. Okay? Now that would be one that has a solution, and the other one that we came across when we were doing graphing was when we had the straight line that came down, but we had another line that was right on top of it. Remember that one? And because it was right on top of it, that meant I had infinite solutions. Now what happens with that when you're using the substitution rule? You solve, just like we solved all of this stuff up here and my variables disappear, the same thing's going to happen here is the variables disappear. But the answer has 2 numbers that are equal. So that might have come out as 2 equals 2, and you would know that you would have an infinite number of solutions to that one. Make sense? Okay? Yes? We're doing all right? Okay. So, let's do some more of these guys and see what we can possibly come up with for solutions to them. Okay. So, can I flip it? Let me get that one out of there. I'll pull this back down here. Here's another right? 6x plus y equals 30, and a negative 3x plus 3y equals 6. hesitant substitution. What do I want to do? I want to get y by itself. First equation, that's wonderful for that because I got a single y. So that means I need to minus 6x from each side, so that's going to leave me with y equals a negative 6x plus 30. Okay, so far? Step 2, take this thing and stick it. Where y is that? Yeah. So it's going to be a negative 3x plus 3 times a negative 6x plus 30 is going to equal 6. So a negative 3x, 3 times a negative 6 is a negative 18x. 3 times 30 is 90. Combine my x's gives me 21, negative 21x plus 90 equals 6. Subtract 90. And that leaves me with a negative 21x is equal to a negative 84. Okay so far? Divide by negative 21, and we find out that x is equal to, x is equal to 4. I done? Just put 4 and I'm finished. Nope. So now I need to take 4, and I need to plug it back into this equation, which I had solved for y, so I can come down here and step 3, plug it back into there. So y equals a negative 6 times 4 plus 30. So y equals a negative 6 times 4 is a negative 24 plus 30. So y equals 6. So when I put my answer in, I'm going to have 4 and 6 for my solution. Okay? So 4 and 6 would be what I have for that one. And then if I want to make sure it's true, plug it back in. Negative 3 times 4 plus 3 times 6 should equal 6. Negative 3 times 4 is a negative 12. 3 times 6 is 18. And a negative 12 and 18 does equal 6. So yay, I did it right. Okay? What do you think? Yes? No? Need to do another one? Another one? Okay. The other varieties that they can end up giving you with some of these is, let me see if I can find one. They give you ones that have decimals in them. An example of that would be x plus y equals 5, and 0.2x plus 0.3y is equal to 0.9. Now, you can do these just leaving the decimals in there, or it's a little easier, and we use this in 8.3 to get rid of the decimals. So how am I going to get rid of the decimals? Well, this is in the tenths, this one's in the tenths, and this one's in the tenths. So I can just multiply that whole thing by 10. That's a kind of a thing we've used back in basic algebra as well. So you can multiply it by 10. If I multiply it by 10, then what happens is my top stays the same, but my bottom becomes 2x plus 3y is equal to 9. And it does make it a little bit easier to work with at that level. So then if I take x plus y equals 5 and solve for one of the letters, which letter do you want to solve for? This one doesn't really make a difference. Let's do for x. Okay. Minus y. We haven't solved for x, but it works the same way. Equals a negative y plus 5. Then take this, plug it into that one for x. So now I can take 2 times a negative y plus 5 plus 3y equals 9. 2 times the negative y is negative 2y. 2 times 5 is 10. Plus 3y equals 9. Negative 2y and 3y leaves me with a y plus 10 equals 9. Subtract 10. And I find y is equal to negative 1. Yeah. So that's y, but now I gotta go back and get x. So x equals a negative times a negative 1. Be real careful when you plug it back in here. You are replacing y, not the negative out in front. So when you replace y, it goes in where that's at, plus 5. And so negative times a negative is a positive 1. So x is really equal to 6. So my point combination is 6 comma negative 1. Okay? Now if you want to really know whether it works exactly, plug it back into this one that has the decimals in it. So if I put 0.2 times 6, that's going to give me 1.2. Negative 1 in here is going to give me a negative 0.3. And if I subtract this from this, I do end up with a 0.9. So I know I did my math correctly. All right. These aren't difficult. They do take a little bit of time to do, but they're not overly difficult to take care of and to work through. They also show you ones that have fractions in them. They don't give you many. I think when I did my certification, I think I only had one that popped up. They have a tendency to give you more that have decimals in them than fractions. But one that might show up is something like this. And so if you have that type of a thing that pops up, you know you need to go through and clear it out with multiplying by your common denominator that you'd happen to have, and then clearing it that way. You will get some fractional stuff in this one though, so you want to be real careful with that. So the top one, what would I multiply it by? Between 4 and 5, what would I come up with for my common denominator? 20. Yeah. So 20 times a negative 3 is a negative 60x. 5 goes into 20. 4 times 1 is a 4y. And 4 goes into 25, so I get a negative 5. And then my bottom one, between 15 and 12, what would I have for common denominator? 60. 60 times x is 60x. 60 times 15 goes into 64. 4 times 1 is a negative 4y. And 12 goes into 60. 5 times 19. What was it? 95. Okay. And does that look like one we would want to end up solving by substitution? Not really. It's probably not a good substitution one, because by the time you move your 60x over and divide by 4, you get quite a few more fractions that are involved with that one, and so forth with it. But if you notice something else about it, x's are different. Notice that? Y's are different. So more than likely, if you run across this situation where your x's are opposites, your y's are opposites, but you got something left over here, it's going to be a no solution. If you can recognize those pieces, because your letters would end up disappearing. And we'll talk about elimination or the addition principle, and that will help you out with this one a lot more than working with it in relationship to substitution. Okay? All right. Story problems. You guys got your sheets out there. There's a couple that pop up in here with your substitution. But in most cases, they end up giving you the equations in some cases. Some other ones they don't, but we'll see what we can do with this part. So, if this were my problem, and we run across these in section 8.5, because mixtures show up in there, in the mixture section they won't give you the equations, but we'll work on getting those together. It says 10 gallons of a salt solution consists of 30% salt. It is the result of mixing a 35% solution with a 25% solution. How many gallons of each of the solutions were used? Let x equal the number of gallons of the 35% solution, and y equals the number of gallons of a 25% solution. The corresponding system is, and so they give us. Notice it's x plus y equals 10 because our total number of gallons that they give me ends up being 10 right here. So this amount plus this amount equals 10. Then what they do is they put each percentage piece in front of its respective value. 35% was your x, 25% was your y, and 10 gallons total was at 30%. So what should we do to solve it? So if we go through and we solve this one, since we're in substitution, we would solve one of these letters. Which one you want to go for, x or y? Any preference? No preference? All right, well, let's shoot for y, or for, yeah, we'll solve for a y. So y is going to equal a negative x plus 10. All I did was move x to the opposite side. To get rid of all this decimal stuff, 10 times that 3 leaves me with a 3, but I still have decimals in here, so this time around I want to multiply by 100 because they're in the hundredths position. So I get 35x plus 25y is equal to 300. So once I get to that point, then plugging this in makes it a little bit easier to do. So I'm going to replace y with this. So 35x plus 25 times a negative x plus 10 is equal to 300. That leaves me with 35x minus 25x plus 250 is equal to 300. Put my x's together, leaves me with 10x minus my 250. 350 minus 250 leaves me with 50. I think we're all okay there. Divide by 10. And I find x is equal to 5 gallons. So how much of the other would I need? So if this is 5, plug it back in here. Negative 5 plus 10. And we find that y is also going to be 5 gallons. And so that's my solution to these. Now, in Hawks, it will say how much of the 35% and how much of the 25%. So you have to be really careful and make sure that you know x is with the 25, or with the 35, and y is with the 25. Because if you get these mixed up, it's going to mark it wrong in Hawks. Okay? So make sure that you get your two pieces in there that you happen to have with that. Yes or no? Okay. And the next one that's on there for your story problems. And after this one, we'll take a break because I think we reached the end of our 8.2. A student bought a calculator and a textbook for a course in algebra. He told his friend that the total cost was $145 without tax, and that the calculator cost $25 more than thrice, what's that going to mean? 3 times the cost of the textbook. What was the cost of each item? So we need to assign variables. Now the nice thing about systems is I don't have to no longer think and say, Kyle, I got to get into one variable, and only one variable is all I can possibly have. In systems, you can have 2. So if I get 2 variables in here, what would they be? Well, I would probably assign my calculator, what? X, or I could assign it C, because it might mean a little bit more. The thing you got to be careful with systems is that you want to get something that's going to go back and tell you what it is. You don't want to have to go back and hunt for what X was. What did I assign X to be? So if I assign my calculator C, and I assign my textbook T, when I'm all done, when I get C and when I get T, what do I have? My answers. Okay? So what do we know? It says he told his friend that the total cost. So that means the calculator plus the textbook is equal to $145. Okay. But he also said the calculator cost $25 more than thrice the cost of the textbook. So what does that mean? That means the calculator is what? $3T's, because it's 3 times the cost of the textbook, but it's also $25 more. Okay, so if we've got that as our values, then what we have to do? Take this and do what to it? Take it and we're going to plug it in where C is at. So I'm going to have 3t plus 25 plus t equals 145. These two are my original equations, so I want to make sure I keep that straight of which ones those were. So 3t plus t, 4t. Subtract 25, and I get 4t is equal to a big whopping 120. Divide by 4, and we find the textbook cost him $30. Okay, but we want to know what's the cost of each item. So now I got to go back and I got to find out what the calculator costs. So if I plug it back here or if I plug it back here, does it make a difference? Not at all. Both are pretty easy to put it in, but I'm going to put it in that second one because then I will have automatically what my value should be. So 3 times 30 is 90. And 90 plus 25 leaves me with 115, I think. Okay. And if I check it, 115 plus 30 is 145. So we did our calculations correctly. Okay on that one? Hopefully. So 8.3 is the third method for our toolbox. So far we've had graphing, and graphing that one wasn't as grand as the substitution one. But now we're even going to get into an easier one than even substitution happens to be, because in 8.3 we get into solving using the addition or elimination method. And it's easier because what happens is you force a variable to disappear. And then solve for the other variable. So within this system, the same kind of stuff happens. You're going to have one solution, and we know what we got to do with that one. We're going to have no solutions, and in no solutions all variables disappear, and the resulting numbers, or the resulting number, is false. So in this case it's going to come out to look like 0 equals 4, which is false, because all your variables are going to go away, or you have infinite number of solutions. And an infinite number of solutions, what takes place with that one is that the variables, disappear, but the result is equal, meaning you're going to get a 0 equals 0 because the numbers disappear. Also. So they're going to go away too. So you can get rid of everything that we possibly could have in there if we had that happen. Some of your systems that you'll be given will be set up just perfect. And you will find that, and you look at them, you've got a letter that disappears. So if I look at these two, I've got x minus 2y equals a negative 9, and x minus, oops, no, I don't want a minus, I want a plus. That's about right? X plus 2y equals 11. So my first step is choose a letter to eliminate. So in this case, what would I eliminate? I'd eliminate my y's because they are opposite. So what you're going to look for to eliminate a letter is the signs are opposite and the numbers match. Now, some of them we're going to have to force it to match, but in this case they do. So we're going to take x minus 2y equals a negative 9 and x plus 2y equals 11. And we're just going to take those two babies and add them together. So step 2 is add the two equations together. So x plus x is 2x. And that's the number one mistake that gets made with these, is that you forget to add your x's together. You just write down x.
So you're always going to add the two equations together?
Yeah, you're always going to add the two equations together. To eliminate a variable. So 2x and a negative 9 and a positive 11, what happens? I get a positive 2, right? Divide by 2. So in step 3, solve for the variable. So I get x is equal to 1. And then step 4 is substitute the answer for step 3 back into one of the equations and solve for the other variable. So if I put 1 back in, I'll just take the first equation and I put 1 minus 2y equals a negative 9. Subtract 1 from both sides. That leaves me with a negative 2y is equal to a negative 9 and negative 1 is a negative 10. Divide by negative 2 and I find y is equal to 5. So my point combination with this one, I'm going to run out of room here, is 1, 5. Plug it back in to check it. 1 plus 2 times 5 is 10. 1 plus 10 does give me 11, and I know I did my math right. Okay. Always check them. It's a great way to saving you a check in your certify within your problems. So make sure that you end up doing that part and coming up with what your value would end up being for that. Okay. All right. So let's do another one. I need it back. Sorry.
Okay.
I heard some disgruntledness out there. I'm going to put it back. Get caught up.
So it doesn't matter which one you plug it back into to find why?
No,
It doesn't matter?
no, not at all, because I could have put 1 back here. If I put 1 here, 1 plus 2y equals 11. Subtract 1 from each side, I get 2y equals 10. Divide by 2, I get 5. So no, it doesn't make a difference in which one you plug it in. So plug it into whatever one you want to. Okay? All right, so now can I flip it? All right. Okay. I want to make you happy out there. I don't want to get upset with not getting what you need. How about this one? X minus 2y equals a negative 9. Negative x, well, I better not do that. I was going to make one up, but I better not, because I know me, if I made one up, I'd be in deep trouble by the time I got around to getting it finished in there. So let me find another one here. I don't want to get into ones that have, oh, here we go. 2x plus 2y equals a negative 28, and negative 2x minus 2y equals a positive 28. So what's going to happen to that whole thing? Eliminate a letter. What letter you want to get rid of? The X's. Okay, but when these are opposites, but these are opposites.
So you could get rid of all of them.
So when I put my line underneath this, what happens? The 2x and the negative 2x are gone. 2y and negative 2y are gone. Negative 28 and a positive 28 are gone. So I get a...
So now you have an infinite.
Infinite number of solutions. Yep, infinite number of solutions. So that's kind of the thing that happens with that one, is that you get some stuff that that goes away. I'm not seeing any that are the I guess I got to go into one that we got to force something to go away, because I don't have any, I'm not getting any that are straightforward. So let's show you that, of what you got to do to make something go away. So if you have 4x minus 3y equals 1, and I have 3x minus 2y equals 4, and that's my system of equations, do I have in there a letter that's going to disappear? Does one want to make it go away? If I just pick one of these? Not easy, does it? Because here I've got two that are the same signs. Here the two are the same signs, so that's not going to help me out much. The numbers, none of the numbers match. So I got to make one go away. So what I'm going to do is I'm going to pick a letter. Which one you want, X's or Y's? It really doesn't make a difference of which one you pick. But once you decide on one, you want to make sure that your goal is to make it disappear. And to make it disappear, that means one sign has to be the opposite of the other sign, and they have to have matching numbers. So if I look at this one and say, well, I'm just going to make X's go away. So I want to identify my X's and say, those are the guys that are going to go away. So what do I have to do to make them go away? Well, if I look at 4 and 3, I know one of those has to be negative and one has to be positive. And so basically what you're looking at is an LCM, or the least common multiple, that both 4 and 3 will go into, which will be what? 12. And we're going to make them both become 12s, but one's going to have to become a negative 12. And the other one is going to have to become a positive 12. Okay? So what does that mean? Well, it means I take the first one and I multiply it by 3. Okay? So 3 times 4 is 12x. 3 times a negative 3 is a negative 9y. And 3 times 1 is 3. Because this was positive, what do I have to do with this one? Well, that one's got to be negative. And because I want to make it to become a 12, I need to multiply it by negative 4. Negative 4 times 3 is a negative 12x. Negative 4 times a negative 2 is a positive 8. And a negative 4 times positive 4. Now notice I multiplied it by everything in there. Don't skip somebody, because it's like, again, not giving them an ice cream cone. They come back and get you because they get your answer wrong. So a positive 12 and a negative 12, what happens? Long gone. A negative 9 and a positive 8. 3 from 16. Negative 13. Divide by negative 1 to get y by itself, and I find y is equal to 13. Okay, am I done? No. I have one piece there, but I need the second one. So I got to take it and decide which one I want to put it back into. So I'm going to put it back in my originals. First one or second one? Any choice? Make any difference? Doesn't make a bit of difference, okay? So we're just going to take the first one. So 4 times x. And if you chose the third or the second one, that's fine as well. So I get 4x. 3 times 13, negative 39. Add 39 to both sides. So I get 4x is equal to 39 plus 1 is 40. Divide by 4. And I find, this case, x is equal to 10. Okay? So my answer is 10, 13. And if I plug it back in, does it work? So I'm going to take the one I didn't work with, plug my two answers into it. So 3 times 10 minus 2 times 13 had better equal 4. Does it? 3 times 10 is 30. 2 times 13 is 26. And 30 minus 26 does equal 4. So the nice thing about all of these is you know if you've got the right answer. You will automatically know. Okay? Just don't get your infinite and your no solutions backwards. Make sure you keep those two straight. But if you get an answer in there, you're going to come up with what your value will be. Okay? Yes or no? Okay. Let's see what we can do with another one here. X plus 0.4y is equal to 3.08. And 0.1x minus y is equal to 0.1. So we have some decimals, so we just got done talking about those in 8.1 or 8.2, I guess it was, where we had decimal pieces in there. So what happens with this? I would, before I try to do anything with it, I'd like to get rid of my decimals. Can we do that, you think? Okay, so let's try to see if we can get rid of that. So the first one, this x plus 0.4y equals 3.08. What would I have to multiply it by? 100. And that's going to leave me with 100x plus 4y, or 40y, sorry, equals 308. Okay. And what about the bottom one? What does it get multiplied by? 10. 10 times this gives me 1x. 10 times y is a minus 10y. And 10 times that is 1. Okay, so now I've got it manipulated, so I have no decimals in it. We okay so far? Okay, so if I get rid of those decimals, I don't have them in there anymore. What letter do you want to get rid of? X's or Y's? Y's? Okay. Reason? Okay. All right. She said it was because it was easier to find this piece to get them to match than to this piece, which is true because you got 100 you can multiply bottom by. But it's also, the other key thing is one's plus and one's minus. So I've got that opposite sign thing helping me out, okay? Because you need an opposite sign anyway. So now, if I take this thing, and do I have to multiply top by anything? Nope. It's just going to stay as 100x plus 40y is equal to 308. But the bottom one is going to get multiplied by 4. So I get 4x minus 40y is equal to 4. Add them together, I get 104x. Y's disappear. 308 plus 4 is 312, I think, right? Divide by 104. And I find x is equal to 3. Plug 3, where do I want to put 3 back in at? Top one or the bottom one? Up here, or down here, or over there? Where do you want to put it? I'd just stick it in the bottom one here. So we're going to have 3 minus 10y is equal to 1. So I'm going to minus 3, and I get negative 10y is equal to 1 from 3 is a negative 2. Divide by negative 10. And I find y is equal to, because we started out with decimals, we can leave it, put it back into decimals, 1/5 or 0.2. I think Hawks will accept either. If I remember right, when I was going through here, it'll accept a fraction or it'll accept a decimal, so whichever one you want to put in there for your answer. So my combination is 3, 0.2. see if it works. Plug it back into, yeah, we'll put it in that original one up there. So 3 plus 0.4 times 0.2 is equal to 3.08. 0.2 times 0.4 is 0.08. So sure enough, it does equal. Okay? So you want to make sure that you check it. So this was the check, that it came out correct. All right or not all right? Yes? Okay. Now, they don't get any, it's just you got to be careful, making sure you multiply by your stuff to end up getting your values to work out with those. And so that's kind of basically the stuff there. Now, if you go back to your story problem sheet, once again, there are two different kinds of story problems that Hawks puts into this section. So we better take a look at those and see what we can possibly do with them. So the first one is money is invested at 2 rates of interest. One rate is 9% and the other is 6%. If there is $500 more invested in the 9% than at the 6%, find the amount invested at each rate if the total annual interest received is $360. Let X equal the amount invested at 9 and Y the amount invested at 6. Yikes. Okay, let's see what we can do with this thing. So money's invested at 2 rates, so we know that part. One rate is 9%, and we said that's our X value, and the other is 6. If there's 500 more invested at 9% than at 6, find the amount invested at each rate if the total interest is this amount. So if the total interest, how do I gain interest? I gain interest by having a certain amount times 9% and a certain amount times 6%, but do I know anything about those? No, I know they're X's and Y's. So if I put this combination together, it's going to be 0.06, whoops, 9, I guess I need to put 9 first, 9x plus 0.06y, and that's all going to equal 360. We okay so far? But it tells me right in this line right here, there's 500 more invested at 9% than at 6%. So what does that mean? Well, that means I have 500 more invested at 9, so that means X is going to have 500 plus Y, because it's the investments that I'm putting in there. We okay with that part? Yes or no? Because it says that there's 500 more invested at 9% than at 6%. So the 6% amount plus the 500 will give me how much is invested at the other. Now, when I look at this one, what does it make you think you want to use out of your toolbox to solve it? We had graphing, probably wouldn't be good graphing it. We had substitution. Looks like a prime substitution, doesn't it? Because if I look at this thing, I could put this in place of X and be done with it right off the bat. But we are in the process of doing, well, elimination. So that means if I subtract Y from this side, I'm going to have X minus Y is equal to 500. Now I have 2 set equations to work with. So I want to clear out my decimals. So I'm going to multiply this equation by what? I'm going to multiply it by 100 because these are all in the hundredths position. So I have 9x plus 6y is equal to 36,000. Put my x minus y underneath that. And what would I have to do? What letter? How can I get rid of a letter in this thing? Get rid of y's, okay? Which means I have to multiply the bottom by 6. So 9x plus 6y equals 3,600. That stays. 6 times x is 6x. 6 times the negative y is negative 6y. And 6 times 500 is 30,000. So 9 plus 6 is 15x. Y's are long gone. And that leaves me with 6,000. Divide by 15. So what's 6,000 divided by 15? What'd you end up with? Do we get an answer? What's x going to be? 6,000 divided by 15. What was it? 400?
Wouldn't it equal 3,000, not 30,000?
What was that again?
Wouldn't it equal 3,000 and not 30,000? It's 500 times 6.
Yes. Yes, 3,000, sorry. Yep, it would be 3,000. Thank you. 36 minus 3,000 is 33. Now we got to go back and redo that. What's 33,000 divided by 15? What would that equal?
2,200.
What was it?
2,200.
2,200? Everybody agree on that one? Yep, 2,200. And so that's how much is invested at X, but what's invested for X, but how much is at Y? What does Y have in it? So I have to put it back in here. So if I plug it back in there, let me do this here, we can cross that off. So if I take 2,200 is equal to 500 plus Y minus 500, how much is invested? 2,200 minus 500 leaves me with, what, 1,700? So 1,700 would be what I would have invested at Y. So that would be my two pieces. Okay or not okay? Yes, maybe, hopefully.
So your point combination would be 2,207.
Yep,
In that order, correct?
yep. Now in Hawks, it will say the amount invested at 9%, and it'll give you a box.
Right.
And I'll give the amount invested at 6%, and they'll give you a box. Okay? They won't have you put it in a point system. They'll have you put it in the two boxes of what it would equal. All right, the last problem of these variety that's in this one that they give you. It says using the formula y equals mx plus b, find the equation of the line determined by the 2 points, -1, 1 and 8, -7. Well, way back when in chapter 4, we took these things and put them in and we solved stuff and we got an equation. But we want to know how this relates to each of these. So in this situation, you're going to put your y value in where y is at, your x value in where, wait a minute, is this right? Yeah, I had it right. 1, I did. And your x value in where x is at, so I have a -1m plus b. And then I'm going to do the same thing with my other point. So -7 is equal to 8m plus b. And that becomes my two equations that I happen to have. So then, because we're in elimination, what letter would you like to eliminate?
The M's.
The m's, okay. So that means we can multiply the top by 8. Because I got to make these match, so 8 times 1 is 8. 8 times a -1 is a -8m. 8 times b is a plus 8b. And the bottom is going to remain a -7 and an 8m plus b. And so 8 minus 7 is 1. B, the m's are gone, but I end up with 9b. Divide by 9. And I find b is equal to 1/9. So am I done? Nope. Now I gotta go back and find out what m equals. So I don't know. I guess I'll plug it in this top one. 1 equals a -m plus 1/9. So if I subtract 1/9, that leaves me with 8/9 is equal to a -m. Divide both sides by -1, which just basically changes the sign. So m is equal to 8/9. So what's my equation? Well, I can plug it back in here and find out that y is equal to a -8/9 x plus 1/9. And I have my solution. That was kind of a tricky piece. They don't give you, but I think there's like maybe 1 or 2 of those. And I will not pick one of those for your test. How's that sound? Guarantee. Guarantee. None of those, okay, will be on there, but they're still thrown in there in the mix. All right, so that's 8-1, 8-2, and 8-3 that we've done with these. So